So we are down to chemical bonding. Let's start with Lewis dot symbol. Lewis dot symbol depicts the structure of an atom using valence electrons. Here, valence electrons are denoted as dots. For representative elements, generally the group number gives us the number of valence electrons. A Lewis dot symbol is composed of two parts, the symbol of the element and the dots. And in assigning the dots, it's important to do it the appropriate way. We will first supply the dots within the four regions shown here before we will supply the other set, and that's it. You can start anywhere for as long as you do it this way. Next is the octet rule. This is formulated by Gilbert Lewis. It states that atoms accept hydrogen bond with other atoms as to attain 8 valence electrons. Hydrogen is an exception because it only needs 2 electrons to attain full valence shell. Basically, this rule states that the reason why there is chemical bonding is because of the desire or the drive of atoms to bond in a way to achieve a configuration similar to a noble gas. They want to be isoelectronic with a noble gas. And it is through sharing electrons with other atoms that they can achieve a complete octet. Now, octet rule is mostly applicable to elements in the second period, which tells us that there are more elements violating the rule than those who are obeying it. And because of that, we need to take into consideration these exceptions. We have 3: incomplete octet, expanded octet, and odd electron species. This is an example of an incomplete octet. As you can see, the central atom has 2, 4, 6 valence electrons. This is an example of odd electron species. The central atom has 2, 4, 6, 7 odd-numbered valence electrons. This is an example of expanded octet. As you can see, there are 2, 4, 6, 8, 10. For an expanded octet, the number of valence electrons of the central atom is greater than 8. Now let's proceed to the different types of bonding. Let's start with ionic bonding. This kind of bonding exists between metal and nonmetals. Here there is electron transfer. This kind of bonding leads to the formation of ions. Metals donate electrons to form cations, while nonmetals accept electrons to form anions. As you can see, when potassium donated its valence electron, it became a positively charged ion, a cation. Now here, chlorine, which will become the recipient of the donated electron, will become negatively charged, a chloride ion with -1 charge. Next is the covalent bonding. This exists between nonmetals. Here, instead of electron transfer, there is electron sharing. Atoms share electrons to obtain full valence shell. As you can see, both of these chlorine ions has 2, 4, 6, 8 valence electrons, 2, 4, 6, 8. And the shared electrons are denoted as bonds. This is a single bond. A single bond contains 2 electrons. Therefore, a double bond is equivalent to 4 electrons. A triple bond is equivalent to 6 electrons. Lastly is metallic bonding. It exists between metals. Here, a sea of electrons exist in the metal structure. These are the free electrons, which is responsible for the strong structure of metals. Now let's proceed to Lewis structures. How do we draw Lewis structures? We have 2 strategies. This is the part 1. This is this method 1. First is to draw the Lewis dot symbol of the individual elements. For example, if we are to draw the Lewis structure of carbon dioxide, we will start with making or drawing the Lewis dot symbol of carbon and oxygen. So this is the Lewis dot symbol for carbon and this is for oxygen. Since in carbon dioxide we have 2 oxygens, so we will need to indicate the Lewis dot symbol for 2 oxygen atoms. Next is to watch out for the element's electronegativity. Based on the values from the periodic table, Next is to watch out for elements' electronegativity. Based on the periodic table, carbon has 2.5, oxygen has 3.5 electronegativity value. Here, we will place the element that has the least electronegativity value at the center. It will serve as the central atom. Also, aside from considering the element's electronegativity, we could also base which element will be at the center or which element will serve as the central atom based on the number of bonds. The element that can accommodate the highest number of bonds will become the central atom. Carbon dioxide can accommodate 4 bonds, oxygen can accommodate 2 bonds. So therefore, carbon will still be the central atom. These are the bonds that each of these elements can accommodate: hydrogen, 1 bond, beryllium, 2 bonds, and so on. Let us continue building the structure of carbon dioxide. So again, the central atom will become carbon. We will exploit the goal of the atoms to have a full valence shell. So basically our goal here is to make all of these atoms to have 8 valence electrons. We will do that by sharing electrons. So we'll start with these electrons. These electrons will constitute a single bond. Let's check. Oxygen has now 2, 4, 6, 7 electrons. Carbon has 2, 4, 6. Oxygen has 2, 4, 6, 7. So we need to share more electrons to obtain full valence shell. Here, we need to share these electrons. Now we have 2 double bonds. Let us check 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. In this case, we already have the structure for carbon dioxide. All of the atoms have full valence shell. We just rearrange the dots, and this is the Lewis structure for carbon dioxide. It has 2 sets of double bonds. For part 2, this is another technique. This is applicable when the structure has no hydrogen. So this is the CDBS technique. C stands for the central atom, D for dots, B for bonds, and S for structure. So how does it work? First, we will determine the central atom. Second is to get the total valence electron of the compound or of the structure, then divide it by the nearest multiple of 8. The remainder will be the number of dots. Next is to subtract the number of valence electrons the central atom has and the number of dots calculated. And then lastly, to proceed to drawing the structure. Let us work on the same example, carbon dioxide. The central atom, we have established this earlier. The central atom is carbon. If it so happens that you don't know the central atom yet, apply the electronegativity technique or the technique that the central atom will be the one who can accommodate the greatest number of bonds. So next is to calculate the number of dots. First, we will get the total amount of valence electron in the structure. We have a carbon atom and 2 oxygen atoms. A carbon atom has 4 valence electrons. 1 oxygen atom has 6 valence electrons times 2 because we have 2 in the structure, so we have 12. The total number of electrons in the structure is 16. Now to get the number of dots, we will divide the total amount of valence electrons to a multiple of 8 nearest to the total, which is also 16. So 16 divided by 16 is 1. But again, the number of dots is dependent on the remainder. So the number of dots of the central atom would be 0. Next is to identify the number of bonds the central atom will make. Our central atom again is carbon. It has 4 valence electrons. We have determined earlier that the central atom will have no dots in the structure. So again, the number of bonds it can accommodate or it will make in the structure is the number of valence electrons that the central atom has minus the number of dots calculated. So 4 minus 0 is 4. Therefore, carbon dioxide will establish 4 bonds. Thus, the structure, let us verify, carbon has no dots in the structure, which is congruent to the result of this step. Also, carbon made 1, 2, 3, 4 dots, which is in congruence to this result. So basically, you can use whichever technique for as long as you do it the appropriate way. Let's have an example.